So networking devices. Okay, this is the topic we are going to discuss right now. Networking devices. So networking devices has been classified into two types. Okay, so or we can say devices has been classified into two types: end user devices and networking devices. Okay, so what is the difference between end user device and networking device? End user device is like a laptop, desktop, which has been used by the user. That is called as end user devices. Laptop, desktop, printer, scanner, or comes under end user devices. Okay. Networking devices like we have router, switch, firewall, load balancer, WAN optimizer, all comes under networking devices. Okay. So devices has been classified into two types: end user devices as well as networking devices. The devices which has been used by the user, directly used by the user. Okay, it's called as end user devices. It may be your PC, laptop, printer, scanner. This all comes under end user devices. When it comes to networking devices, the device which has been used in the network. Okay, when I say in the network, we use switch, then hub, router, firewall. Okay, this all comes under networking devices. So we'll go it one by one. So you can see here we are going to discuss about networking devices here. Networking device we are going to discuss repeater, hub, switch, router, and firewall. Repeater, hub, switch, router, and firewall. Repeater, where we are using repeater. Okay, where we are using repeater. Suppose, for example, if I forward any signal, okay, I am going to forward some signal here. If I forward any signal like a, I'm forwarding, it will be in the form of what? Zeros to one, right? It will be in the form of zeros to one here. Okay, I'm forwarding some signal here. 0, 1, 0, 1, 0, 1. It's forwarding. But after few distance, my signal getting what? Attenuated, like that. Signal getting attenuated. Within few seconds, automatic signal, there is no signal at all. So in this case, what we have to do? Okay, in this case, what we have to do is, here we have to use a device called a repeater. Okay, so when the signal, whereas the signal getting weak actually, we are going to use a device called a repeater. We are going to use a device called a repeater. Okay, to regenerate the original signal. Okay, repeater has been used to regenerate the original signal. Okay, understood here? Or we can say converting the weak signal into strong signal. Okay, regenerating the original signal because my signal is getting degraded, right? Okay, signal getting distorted, we can say, because like a weak when I send a strong signal, okay, because of external signals, might be externally we have multiple signals available, noise signal, FM signal, AM signal, okay, a lot of signals available, right? My signal getting attenuated, because of external signal. So after few hours or few distance actually, my signal is getting attenuated. I can get there is no signal at all. In this case, what I have to do, sir? I have to regenerate my original signal. Regenerate my original signal. That is the thing I have to do. Or converting my weak signal into strong signal. Converting my weak signal into strong signal. Okay, that is called repeater. Okay. So, which layer it operates? We should know about layer also, because each device works in different layers. Okay. So, layer in the sense like OSA model. We should understand about OSA model. In 1980, okay, in 1980s, example, in 1980s, okay. So, we have IBM company also available. IBM company was available during the period, and also Apple company also available. Okay, so IBM, they manufacture their own PC. Example, I'm telling, they manufacture their own PC. Okay, Apple, they manufacture their own PC. Apple also, they are manufacturing their own PC here. They are manufacturing. If they want to communicate with each other, yes, they can communicate. IBM PC can communicate with IBM PC. IBM PC can communicate with IBM PC. Similarly, Apple, they can also communicate with each other. Apple can communicate with Apple. Apple can communicate with Apple. But if you want to communicate my IBM PC to my Apple environment, it was not possible during the period, right? 1980s and we cannot able to communicate my IBM PC to Apple PC. Why? Any reason for it? I cannot communicate. Similarly, if you want to communicate my Apple PC to IBM environment, Apple PC to my IBM environment, I cannot able to communicate at all. Here I cannot able to communicate. Any reason why I am not able to communicate? I'm not able to communicate at all. If I want to communicate with IBM to Apple or Apple with IBM, I cannot able to communicate at all. It won't work at all. When? 1980. So the reason is nothing but each company follow the own standard of manufacturing the devices. Each company follow the own standard of manufacturing the devices. IBM, they have their own standard. Apple, they have their own standard. So if they want to communicate with a different network, different PC, different devices, they cannot communicate. Similarly, for example, if you want to communicate with Cisco with the dealing, they cannot able to communicate during the period. Dealing with Cisco, they cannot able to communicate because they are following the own standard. IBM, they have own standard. Apple, they have own standard. Cisco, they have own standard. Dealing, they have own standard. Each company having their own standard. They have their own route. They have their own protocol. They cannot able to communicate. If they want to communicate, what they have to do? They have to follow some kind of common standard. That is nothing but what? That is called as OSI model. Okay, OSI, Open System Interconnect model. It has been developed by ISO, Open System Interconnect model. It has been developed by ISO. So here you can see here, okay, 7 layers are available, right? What are 7 layers are available? You can see 7 layers here: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Okay, it is OSM model here. 7 layers are available. So we are going to learn about this OSM model later on. Okay, so understood here. 7 layers are available. So if they want you here, the device repeater, I told you, right? Repeater operates in physical layer. Okay, repeater operates in physical layer. We are going to discuss about hub also. Hub also operate in physical layer. So that means what? Repeater as well as hub. Operate in physical layer. Okay. Here a router or switch comes under data link layer, and also bridge comes under data link layer. A router comes under network layer. Router comes under network layer. Apart from that, firewall operate in multiple firewall. Okay, multiple layers actually. Like a firewall operated data link layer, firewall operated network layer, application layer firewall is also available. Okay, firewall operated in multiple layers. Okay, so we are going to discuss repeater here. A repeater. So this is the first device we are going to discuss. Repeater, how we can explain this one? Repeater, say repeater here. So you can see the image of a repeater here. How it look like? How many ports are available here? 2 ports are available. One is input port, one is output port. So it receives the signal via input port, okay, regenerate the signal and transmit signal via output port. So in the diagram you can see here, this is nothing but what? Input port here. Okay, this is nothing but output port. Okay, so it receives signal via input port, regenerate the signal, transmit signal via output port. That's called repeater solver. So when you say repeater here, it's a layer 1 device. Layer 1, right? It's called a layer 1, layer 2, layer 3, layer 4, layer 5, up to layer 7. Okay. So when I say repeater here, it's a layer 1 device. Layer 1 device operating at, okay, repeater is a layer 1 device operating at physical layer. It has two ports, input port and output port. It receives signal via input port, regenerate and transmit signal via output port. So the repeater is okay. Repeater is also called as what? When say repeater here, amplifier or booster. We can say amplifier, right? Amplifier signal, right? Booster. Okay. So we can say amplifier or booster. That is what the different repeater is all about here. You can see here how it look like. How it look like. You can see this. It converting the weak signal into strong signal. It converting the weak signal into strong signal. Weak signal into strong signal here. Okay, that is the purpose of repeater. So it has two ports, input port and output port. Okay, you can see here, a repeater is a layer 1 device. It's a layer 1 device operating at physical layer. It's a layer 1 device operating at physical layer. It has two ports, input port and output port. So it receives signal via input port, regenerate the signal and transmit signal via output port. Okay, it converting the weak signal into strong signal. Because of that, it's also called as amplifier or booster. Clear? Next device, hub. Okay, hub. How it look like here? Hub look like here. So you can see here, hub look like. Okay. So what we could do? If this is a device, right? What is the purpose of hub actually? We can see multiple ports are available, right? So with this multiple ports, what we can do here? We can connect multiple PC. That's the purpose of hub. We can connect multiple PC. My question here is, currently are we using hub or not? No, we are not using hub actually. Initial days we used actually. 10 years back we used hub actually. 15 years back we used hub. But currently we are not using hub. Currently we are not using hub. Any reason for it? Why we are not using hub actually? What hub will do, sir? So why we are not using right now? Okay. So we understood that hub actually, hub is a layer 1 device, right? Hub is a layer 1 device. Okay. Hub is a layer 1 device operating at physical layer. Same thing. Hub is a layer 1 device operating physical layer. But it has how many ports are available? It has many ports. Why I am saying many ports here? There are 4 ports hub available, 2 ports available, 8 ports hub available, 16 ports hub also available. It has many ports. Okay. So what is the purpose here? We can connect multiple PC, multiple device we can connect. Okay. Here we understood here. Hub is a layer 1 device operating at physical layer. It has many ports to connect many PC. Why you are connecting here? Why you are connecting multiple PC here? They can communicate, right? For sharing of information as well as sharing of resource. Okay. But what is the drawback? Why we are not using? We have a lot of advantage, right? But why we are using? Why we are not using right now? Okay, the problem is nothing but problem. What is the drawback here? When I forward 100 Mbps signal here, when I forward 100 Mbps signal via one port here, if I have 10 PC available, what will happen, sir? 100 divided by 10. 100 divided by 10. What will happen? 100 divided by 10 here comes under what? 10 here. 100 divided by 10 comes under 10 here. That means it will, okay, even though if you forward 100 Mbps, okay, the device which is connected here can receive only 10 Mbps only. That means what? The signal getting divided. Okay, divide the signal state. That is the drawback of hub actually. Divide the signal state. That is the drawback of hub. Okay. Another drawback. What is the other drawback, sir? Always broadcast. Sir, I want to forward from A to. I want to forward the information from A2 lost PC. I want to forward the information A to D. I want to forward the information from A to D. What will happen here? Even though if I forward the information from A to D, but not only A to D will receive the information, all the devices connected here will receive the information. That is called as what? Always broadcast. There is no MAC table available here for saving the information MAC address. Okay, to forward only to the particular PC here. But whenever you are forwarding the information, always it goes for broadcasting. Broadcasting means one to all. Go for broadcast. So here, hub. Hub is a layer 1 device, right? Hub is a layer 1 device operating at physical layer. Okay, operating physical layer. It has many ports to connect many PC. We know it has many ports are available to connect many PC for sharing of information as well as for sharing of resource. Okay, so it is also called as multi-port repeater. It's also called a multi-port repeater. The drawback is nothing but always broadcast. That is the drawback. Another divide the signal state. Other drawback. Operate in half duplex mode. We already said it about half duplex. What is half duplex? Two-way communication, one at a time. Okay. So this is the drawback of hub. Okay. But currently we are not using hub. So hub. Currently, then what we are using right now? We are using switch. Switch is the device we are using. It looks like same. You can see here, switch. This is the device we are using. How it look like? You can see the diagram here, image here. Okay, this is the image of the switch. Okay. So here also you can see multiple ports are available. Multiple ports are available. If you have multiple ports available, we can connect multiple devices, right? Multiple PC also we can connect, right? Multiple PC will connect. But which layer it operates here? Which layer it operates? It operates in the layer 2, data link layer. Okay, it operates in layer 2, data link layer. So in hub actually, okay, advantage. What is the advantage here? Even if you forward 100 Mbps signal, all the devices will get 100 Mbps. Okay, it does not divide the signal state. It does not divide the signal state. What is other drawback available? Always broadcast, right? But here, go for broadcasting only for first time. First time broadcast. Next time onwards, unicast. During first time broadcasting, we learn the address and store it in a table called MAC table. Learn the address and store it in the table called MAC table. Okay, store in the table called MAC table. Next time onwards, when it want to forward the information from one device to another, what will happen? By referring to the MAC table, it forward the information. Okay, this is called as what? It is the advantage of a switch. One more advantage, full duplex. Full duplex means what? Two-way communication, both at a time. So, okay, when to discuss a switch here, switch is a layer 2 device operating at data link layer. It has many ports to connect many PC. Sharing of information, sharing of resource. Advantage here, first time broadcasting, next time unicast. First time broadcast, next time unicast. One more advantage, does not divide the signal state. Does not divide the signal state and works in the full duplex mode. Okay, that is the advantage of switch here. So you can see here, switch is a layer 2 device operating at data link layer. It has many ports to connect many PC. Sharing of information as well as sharing of resource. Okay, it has one more information. It has hardware. It has a hardware called ASIC, Application Specific Information Circuit, Integrated Circuit. Here only, okay, it store the MAC address. So advantage here I can say, okay, three advantage here. First time broadcast, next time onwards unicast, does not divide the signal strength, works in the full duplex mode. What is the function of switch here? Function. We are going to discuss about the function later. Address learning, flooding or broadcasting, loop avoidance. That is the function of switch. Address learning, flooding or broadcasting, loop avoidance. These are the function of switch. Consider this is switch here. It has been connected with PC here. It has been connected with PC here. Okay, so assuming here AA is nothing but the MAC address, BB is nothing but the MAC address here, CC is the MAC address, DD is the MAC address. Okay, the port number I can say one port number here 1, 2, 3, 4. Now I want to forward the information from A to B. I want to forward the information from A to B. So if I want to forward the information from A to B, A is the source address, B is the destination. Okay, A is the source, B is the destination. So we know the function of switch. What are the three functions of switch here? Address learning, flooding and broadcasting, and loop avoidance. This is the function of switch here. Address learning, flooding and broadcasting, loop avoidance. This is the function of switch. Okay. So now I want to forward the information from A to B. What switch will do? We'll discuss. Okay. I want to forward the information from A to B. What switch will do if I forward the information from A to B here? So now I am sending the information from A to B, right? When you forward any information from A here, it reaches my first port number here. Okay, it reaches my first port number. What switch will do? Switch will refer the MAC table. The information which is available there in the MAC table is nothing but MAC address along with the port number. It will be available there in the MAC table. Okay, MAC address along with the port numbers are available there in the MAC table. MAC address along with the port number available there in the MAC table. So when you forward the information to the switch here, what switch will do? First step is nothing but what? Address learning. It learned the address. That is the first step. Address learning. It learned the address. When you forward the information here, the switch will learn the MAC address of the particular PC. What is the MAC address here? AE. It is the example we are discussing here. AE. So it learned the MAC address of the PC here. MAC address AE. Which port it received here? It received on the port number 1 here. It has been learned when you forward the information. Next, after learning here, it check where the information need to be forwarded. Where I need to forward the information from A to B. So I need to forward to B. It's checking whether B is available there in the table or not. So first time B is not available. Understood here? First time B is not available. If it is not available, what do you have to do, sir? If available, what I have to do? If it is available there, I have to go for unicast. If it is not available, I have to go for broadcast. Okay. If it is available, I have to go for unicast. If it is not available, I have to go for broadcast. So right now, the information is not available. If not available, what I have to do? I have to go for broadcast. So what will happen here? Even though if I forward the information here, it's not available there, right? It send it to all the other ports except the receiving port. It forward it to all the other ports here. This port, this is also forwarded here. This port is forwarded here. It forward to all the other port except the receiving port. Okay, that means one port. You don't forward to one port. Remaining port 2, 3, 4. It has been forwarded. When information reaches here, what this device will do, sir? Checking whether it belongs to D or not. It's not belongs to D. Actually, we are forwarding from A to B, right? It's not belongs to D. So in the information which has been forwarded, getting discarded, rejected. Here also, when you forward the information here, whatever information coming here, getting discarded. Here also, what will happen here? But when it comes here, we are forwarding to A to B, right? What A, B will do? They will accept the information because it belongs to B only. The acceptation. After accepting, it has to reply, acknowledge back, right? Acknowledgement has been forwarded here from B to E. So it has to be forwarded B to A. So what will happen here? Again, when B is forwarding the information, it comes to my switch here. Okay, whenever new information comes to my switch, what will do? It goes for address learning. Any new information comes, it goes for address learning. It learn the address. What is the address here? It learn the address. BB is the MAC address. What is the port number? It learned the port number 2. Okay. So after learning, it checks where I need to forward. I need to forward to A. Checking whether A is MAC address available there in the table or not. Yes, already available there. But what is the port number? 1. Directly forward from 2 to 1 here. Directly forward 2 to 1. So next time onwards, you want to forward the information from A to B. Okay, what will happen here? A is forwarding the information. Okay, next time onwards, you are forwarding the information from A to B, right? When you will forward the information A to B, forwarding here. It comes to switch here. Address learning, checking whether A is available. Yes, A is already available there. Okay, then where I need to forward the information? B. Checking B is available. Yes, B is also available there. Port number 2. Directly forward from A to B. Directly forward from B to E. That means what? First time only goes for broadcasting. Next time onwards, unicast. If information is not available, go for broadcast. If information available there, go for unicast. Okay, that's not the second one, broadcasting. Okay, if not available, go for broadcast. If available, go for. Okay, so this one is nothing but loop avoidance. This topic we'll discuss in the STP, spanning tree protocol. How spanning tree protocol has been used for avoiding the loop in the switching network. How it prevent the loop in the switching network. We'll study it during the prayer. Okay. So we understood that switch is a layer 2 device operating at data link layer. It has many ports to connect many PC, sharing of information as well as sharing of resource. It has a hardware called ASIC, application specific integrated circuit. Okay, switch operate in the same network. Okay, we'll discuss switch operate in the same network. What is the advantage here? First time only goes for broadcasting. Next time onwards unicast. Okay, does not divide the signal state. It works in the full duplex mode. What is function here? Address learning, flooding or broadcasting, as well as loop avoidance. These are three functions available directly. Switch off. We have multiple functions available. Main function. Next, router. How the router will look like? This is the router it's all about. So there are different model router available. Both are Cisco router only. So when you say router here, what is the purpose? If I want to connect two different network, okay, I got to use a router. If you want to connect same network, I have to use switch. You can see here, used to connect same network. So that means, what is meaning same network here? Okay, same network you can see here. The device, if I have multiple pieces available in my network, if I have multiple pieces available there in my network here, example, these are the PC available, multiple PC available here. Okay, so the PC will have the same network. That means 10.0.0. Okay, 0 is the network address. The first IP will be 10.0.0.1. 10.0.0.2 is the second IP. Okay, 10.0.3 is the third IP. 10.04 is the 4th IP. 10.05 is the 5th IP. So what will happen here? It will assign the IP address one by one. It will assign the IP address here. So you can see here this IP address has been assigned for this PC. Okay. So this IP address has been assigned here. And then what will happen here? This IP address assigned for another PC here. Okay. So this IP address will be assigned here 10.0.0.2. Here this IP will be 10.0.0.3, 10.0.0.4. So one by one it will assign. Okay. So that means what? All on the same network. You can see here all on the same network. Same network means what? Start only with the 10 here. Same network. All are in the same network here. Okay. Sub must 255.0.0.0. That is sub must here 255.0.0.0. So we can see the same. All are in the same network. 10 network here, 10 network, 10 network, 10 network. All on the same network. So if you want to connect different network, what I have to use? Okay, that means what? We have to use router. So router is a device which has been used to connecting different network. Okay, you can see here different network here. Like this is one network here. Okay, one network here, another network here. Okay, so two networks. Example, you can say here two network. I want to see here two network. So the PC, what is the IP address we can assign? Okay, we can assign one end will be the 10 network IP address, another end will be 20 network we can assign. So easy to understand. 10 network and 20 network. So here, I want to take 10 network here, right? This end, left side I want to take 10 network here, and I say 10.0.0.0. Right hand side I want to take 20 network here. Okay. So this is the network I want to assign here. So this is the network I want to assign here, 20.0.0.0. So here I can say 10.0.0.1 here, 10.0.0.2, 10.0.0.3. So you can see all are the same at 10.0.3, 10.0.0.4, 10.0.0.5. Okay. When it comes here, it will be like what? 20.0.0.1 here, 20.0.0.2, 20.0.0.3, 20.0.0.4, 20.0.0.5. So both are the what? Different network. So that means what? Router has been used for connecting different network. Okay. So because here we have 10 network available, here we have 20 network. So if you want to connect two different network, I have to go for router. So router is a device for connecting two different network. Okay. Here you can see it's a layer 3 device operating at network layer. Okay, it's a layer 3 device. It's a layer 3 device operating at network layer. Layer 3 operating network layer. It's used to connect different network. When I say different network here, I can connect LAN to LAN also I can connect. If you want to connect with the LAN to WAN, I can use router. Or we can say WAN to WAN also. If you want to connect, I can use router. Okay. So router has been used for connecting different network here. LAN to WAN, WAN to WAN, and LAN to LAN also we can use. If you want to connect these two different networks, we have to go for router. Example here we can say LAN to LAN. That's what we discussed over 10 network and 20 network here. We need router. We need router to communicate. Similarly, LAN to WAN, we need router. Okay, WAN to WAN. Airtel, this is nothing but some ISP, BSNL ISP, some other ISP. Okay, might be Airtel. If you want to communicate, we have to use a router only. So we understood here, a router is a layer 3 device operating at network layer. It has many ports and many interfaces also available. It's used to connect two different networks, LAN to WAN, WAN to WAN, and LAN to LAN also. Firewall. So what is the purpose of firewall? Firewall is a security device. Firewall is a security device to protect the private network. If you want to protect my network, if you want to protect my company, if you want to protect my company, if you want to protect my network, we need firewall. Okay, firewall is a security device to protect the network. Here you can see here. So this is the internet. The internet, we have the internet, we know that unnecessary traffic or malicious traffic also available. You can see here the red one represents the malicious traffic, okay, and the green one represents genuine traffic. So what firewall is doing here, okay, automatically block the malicious traffic, allowing only the genuine traffic. Okay, it's a security device. Physically, we can say, okay, it's a security device. Firewall is a security device to protect the private network. This is my private network, right? Okay, my home network, my office network. That's private. This is public. Internet is a public. Okay, I want to protect my private network from public. What is required for me? Firewall. Firewall is required for protecting my company, protect my private network. Okay, from where? From internet. Because internet have all kind of traffics are available there in the internet. Okay, malicious traffic also available, genuine traffic also available. But I want to protect my network. We need firewall. What firewall will do, sir? Firewall will block or permit based on the condition. Permit the packet or deny the packet based on the condition. Whatever condition I define here, in my as per company rule, I don't want to allow, okay, some traffic. Might be I can say I don't want to give access for YouTube. I don't want to give access for, okay, Facebook from in my company. Okay, yes, we can do it by using firewall. That comes under application layer firewall. Okay, similarly, multiple firewalls available. We can block based on the MAC address. We can block the traffic based on the IP address. We can block the traffic based on the, okay, session ID. We can block the traffic based on the port number also. We can block the traffic based on the application also. So firewall operates in multiple layers. Based on the condition, okay, firewall operates. So you can see here, firewall is a security device to protect the private network. Firewall is a security device to protect the private network. It can permit the packet or deny the packet. It can permit the packet or deny the packet based on the condition. Permit refers allow, deny refers block. Okay, permit refers allow, deny refers block here. What firewall do? Based on the condition, it can permit or deny the traffic here. Okay, when you say condition here, it may be MAC address, it may be IP address, it may be port number, it may be section ID, it may be application. It's condition. Based on condition, I can block it or I can permit it. It's available in two forms. Okay, so hardware or firewall also available, software firewall also available. Okay, hardware firewall also available, software also available. There are two types of firewalls available: personal firewall and network firewall. Personal firewall. What is my personal firewall? Is when the inbuilt along with the OS. Inbuilt along with the OS is called a personal firewall. Network firewall. When I say network firewall, to protect the complete network, it's called a network firewall. Personal firewall inbuilt along with the OS. Network firewall to protect the complete network is called a network firewall. Okay. If you want to protect only my computer, we have personal firewall available. Where we can say personal firewall, we can say in control panel. When you type Windows firewall, we can see personal firewall. Okay, the control panel we can see firewall available, right? That is called as personal firewall. Okay, but network firewall, we can keep. If you want to make the network to be more secure, you can have network firewall to protect the complete network. It's called a network firewall. Firewall operate in multiple layer. I told you, right? Okay, you can see layer 2. Layer 2 firewall available, which you operate it, okay, based on the MAC address. Layer 3, which operate in IP address. Layer 4 firewall also available, port number, based on the port number, based on session ID, based on the application, can permit the packet or deny the packet. There are a lot of vendors available, lot of companies available for firewall companies. We can say here, okay, vendor I can say Cisco, ASA, Juniper, Aruba, Checkpoint, FortiGate, Palo Alto. Currently, the market, firewall, okay, firewall you can say, most of the company they are using Palo Alto, FortiGate and Checkpoint firewall. Okay, Cisco Firewall, one more firewall also available. These are the very good firewall currently in the market. This is the firewall we are using. Okay, good. Thank you. We discuss about what networking devices here. Okay, networking devices. So first we discuss about devices. Okay, when I say devices, there are two types of devices available. One is nothing but end user device and national networking device. End user device nothing but the devices which has been used by the user. It may be PC, laptop, printer, scanner. It's called end user device. When I say networking device, a router, switch, firewall, hub, repeater, it all comes under networking devices. In networking devices, we discussed about repeater, hub, switch, router, and firewall. A repeater is a layer 1 device operating at physical layer. It has two ports, input port and output port. It receives signal via input port, regenerates signal, and transmits signal via output port. Okay, that is the purpose. That is a repeater. Converting the weak signal into strong signal is called as a repeater. It's also called as amplifier or booster. When you say hub is a layer 1 device operating at physical layer. It has multiple ports to connect multiple PC, sharing of information and sharing of resource. But currently we are not using hub. What is the drawback here? Always broadcast. Another drawback, divide the signal stream. Apart from that, hub plus also a drawback for hub here. Currently we are not using. Currently we are using switch. Switch is a layer 2 device operating at data link layer. It has many ports and it has many ports to connect many PC. Sharing of information as well as sharing of resource. Okay, in switch here, it's an intelligent device because it stores the information about the MAC table. Okay, store the information of MAC address in the MAC table because it has a hardware called ASIC, application specific integrated circuit, which has been used for storing the MAC address. What is the advantage here? First time only broadcasting, next time onwards unicast. Does not divide the signal state. It works in what? Full duplex mode. It operates in full duplex. Advantage we discuss, function also we discuss. Address learning, flooding and broadcasting, loop products. That is function. Router. Router is a layer 3 device operating at network layer. It has many ports and many interfaces available, but it used to connect different network. When I say different network here, LAN to WAN, WAN to WAN, and LAN to LAN. All are the different network. That's what we are doing for router. So you can see different for connecting different network, we are using router. Next, firewall. Firewall is a secure device to protect the private network. It can permit the packet or deny the packet based on the condition. Permit refers allow, deny refers block. Okay, firewall prevent unauthorized access to the private network here. There are two types of firewall available: personal firewall and network firewall. Personal firewall to protect your PC. Network firewall to protect the complete network. It's called network firewall. It operates in multiple layers. It operates layer 2, it operates layer 3, it operates layer 4, it operates layer 5, it operates layer 7. Okay, there are different companies also available. Okay, different vendors are available. So you can say FortiGate, Juniper, Palo Alto, Aruba, Checkpoint, lot of firewalls are available. Okay.